But kids, I know my college algebra students rely on that. They're not thinking about for each x there should be one y. They're just doing mechanical. And I guess we're trying to get it's again very procedural.
Right.
We just draw the vertical line. It hits it once. Good.
And that also links with the modality thing. Linking different modalities. I'm sorry.
Yeah.
I just see it.
No, that's true.
I have
Thanks. That's true. So the vertical line test is fine for just an initial, but we're trying to really stress it's more a way of showing them, so it's more showing the process, but the kids need some basic understanding. So when they get to something like polar functions, polar coordinates, they'll see that, oh yeah, there are other ways. Also, there was another one, I can't remember what it is. But it's just, again, we're looking for more conceptual, and this is more very mechanical. Okay, there are families of functions. You know that, for example, the linear functions basically form one family, but we could also have subgroups. It's not my day. I got up this morning.
Is that you or me?
No, it's not me.
It's that phone like
It's this phone. Is this you, Ellen?
That's me. Answer it, Mary, and tell them I'm not available.
Sure. I don't even know how to answer, Ellen.
Okay. I have to turn it high enough or I miss Jan's calls.
And then we saw this.
We can look at linear functions, if we want to just take them. We can look at them as families of functions in the sense of those that have the same slope. And we can look at the similar triangle ratios to be determining which ones would fit into that category. Okay, so we've got lots of different ones. Essential understandings, do we think about how we can add functions? They have to have the same domain and mapping into real numbers. All right, we can compose functions, we can put functions together. Kids don't have a good sense of that. What does that mean, f of g of x? And what I talk about is, for example, if you were making anything really, and then you're going to refine it. So if you had a mold of something, let's say you were making some kind of ceramic piece, you've got to then fix the seams. Or something comes to you, for example, you get a raw material, you do something to it. Or when we go to the store, we don't see it as much anymore when you get the sum of the purchases that you made. And then what does the cash register do? It figures out the tax and adds that on. But the first thing it does is add up. You get the sum of the items. And then goes to working from there. So we can also talk about shifting and scaling and how we can move graphs. And that was the one that you mentioned yesterday, for example, in Max's talk. We had that example. Okay, and then multiple representations of functions. I think we've seen quite a bit of that. We know it's we can talk about the Freyer model, where we're looking at it algebraically, graphically, we can talk about it verbal, and what's the third one? I was going to say symbolically. Real world, but symbolic, yes, a real world application would be fun. Okay. And we have to understand that changing the way the function is represented doesn't change the function. So as Ellen was talking before, with the equations, when you're solving them step by step, the same thing is true with a function. If you change it in some way, to simplify it, in other words, going from the vertex form of a parabola into the standard form of a parabola, it's still the same parabola. We're just representing it in a different way to get different information. Okay, I see it. And then obviously some representations are more useful than others. And it's so important for kids to see the links between the algebraic and the graphical, because so many of them have no sense of what the zeros of a polynomial are except on a graph. And then you try and get them to show that algebraically, and oh, those numbers are the same. Why is that? All right. So I guess the big idea I want to leave you with is the thought that we need to think about functions, and what I didn't, they start off really in elementary school, where we look at patterns. All right, so we're looking at patterns of development, And then we're also looking at, as we move into, trying to see where, here, the elementary school is studying patterns and informal ideas of variables. And then in middle school, they're representing the patterns in tables, okay? And they're looking at covariation. And then when they get to high school, they're trying to analyze the relationship and construct families of functions. One of the best, or one of the underlying concepts would be looking at rate of change. And we're looking at that throughout, because we're going all the way up through calculus and differential equations with rate of change. So kids need to get that basic understanding in elementary, middle, and high school. We're constantly developing those ideas and concepts, and we're trying to get them to think more about the concept versus what it is procedurally. Okay? Thank you.
Thank you, Mary.